In this video, we will cover 6 short modules. We'll start with the big idea behind functions, walk through their anatomy, and learn how to call them effectively. Let's begin with part 1, the big idea. Before diving into syntax, we'll explore exactly what a function is and why they are essential to programming. Simply put, a function is a named block of instructions that you can reuse. You provide ingredients, known as arguments, the code runs, and it returns a finished result. You likely use the concept of functions every day. Think of a recipe, a calculator, a microwave, or an ATM. Each takes specific input, performs a hidden set of steps, and gives you an output. Why bother with functions? They allow you to solve a problem once and reuse that solution forever. This promotes code reuse, improves clarity, and significantly reduces bugs. Life without functions means constant repetition. If you need to perform the same task multiple times, you end up copying and pasting code, which makes it error-prone and hard to maintain. With functions, you define the logic in one place. If you ever need to make a change, you update that single definition, and every part of your program is updated instantly. This follows the golden rule of programming, DRY, or don't repeat yourself. Every piece of knowledge should live in a single, unambiguous place. To summarize the shape of every function, you have arguments as your inputs, the function body as your process, and a return value as your output. Now let's move to part 2, anatomy and syntax. We'll break down the specific components that make up a Python function. A function has 6 key parts: the def keyword, the name, parameters, an optional docstring, the body, and the return statement. Every definition starts with the def keyword. This tells Python that a new function is being created, followed by the function name and any parameters. When naming your functions, follow standard conventions. Use lowercase letters with underscores, keep names descriptive, and avoid using reserved Python keywords. Parameters are essentially empty boxes. When you define the function, you name these boxes, and when you call the function, you fill them with actual values. Next, let's cover colons and indentation. In Python, whitespace isn't just for looks. It defines the structure of your code. The colon marks the end of the definition line, and everything inside the function must be indented. The function body consists of the indented lines that perform the actual work. This is where you include calculations, logical decisions like loops or if statements, and finally, the return statement to output your result. DOC strings are a great way to include built-in notes within your code. Written in triple quotes at the top, they remind you what the function does and can be accessed automatically by help functions. The return statement is how your function hands data back to the caller. Remember, it sends a value out, ends the function immediately, and if omitted, your function will quietly return none. Here is a complete function in action. Notice how we define it. Include a docstring, and use logic to determine the output. Calling it twice shows exactly how it handles different inputs. Memorizing this syntax skeleton is the key to writing any function. Remember the keyword def, the name, the parameters, the docstring, the body, and the return value. Now we move to part 3, calling functions. While defining a function sets the recipe, calling is what actually cooks the meal and brings your code to life. Think of it as the difference between writing instructions and executing them. Defining creates the function, but it sits idle until you use its name and parentheses to call it into action. Anatomy of a call always includes 3 parts: the function name, the parentheses to trigger execution, and the arguments, which are the specific values you pass into the function. The call lifecycle follows these steps. You reach the call in your code, pass the arguments, the function body runs top to bottom, and it returns a result that your program can then continue with. Some functions require no arguments at all, but they still need those empty parentheses to run. Be careful not to omit them, as that would refer to the function object rather than executing the code. Once a function returns a value, that data is ready to use. You can store it in a variable, perform math with it, or include it directly in strings or logic, just like any other data type. When you call a function, Python pauses the current code, jumps into the function's logic, and returns the result back to the exact location where the call was made. One of the most powerful features is having functions call other functions. By creating small, focused blocks of code, you can build complex systems out of simple, reliable building blocks. Finally, avoid common pitfalls. Don't forget the parentheses. Ensure you pass the right number of arguments. Define before you call, and remember to use quote 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 whoa whoa, and rather than just printing if you need the data back. Moving on to part 4, inputs. We will look at how arguments and parameters function as the values that flow into your code, providing the flexibility to handle different tasks. The most important distinction for beginners is the difference between a parameter and an argument. A parameter is the named placeholder in your definition, while an argument is the actual value you pass when calling it. First, we have positional arguments. These are matched to parameters based entirely on their order. In this example, swapping the order of the arguments would change the result. Alternatively, you can use keyword arguments. By explicitly naming the parameter during the call, the order of the arguments no longer matters. This makes your code much clearer. If you need to mix both styles, remember the golden rule. All positional arguments must come before any keyword arguments. Otherwise, Python will raise a syntax error. Default parameter values allow your functions to be even more flexible. By providing a fallback value in your definition, callers can choose to skip that parameter entirely. This shows how a single function can be called in 3 different ways. You can use the defaults, override some, or replace all of them depending on your specific need. For functions that need to handle an arbitrary number of positional inputs, use the *args syntax. This collects any extra arguments into a tuple for easy processing. Similarly, the *quarg syntax collects any extra keyword arguments into a dictionary. While you might not need this as a beginner, it is excellent to recognize in more advanced code. In short, we have 5 ways to handle inputs: positional, keyword, default values, new args for many positional values, and *wargs for many named inputs. Welcome to Part 5, Outputs and Scope. Now that we have covered how to send data into a function, let's learn how to get results back out and manage variable accessibility. A common point of confusion is print versus return. Print simply shows a value on your screen, whereas return gives that value back to your program so it can be stored or used later. The return keyword is essential. Not only does it pass data back to the caller, but it also signals that the function has finished its task and should exit immediately. You can even return multiple values by separating them with commas. Python automatically packages them into a tuple, which you can easily unpack elsewhere in your code. Finally, if a function lacks a return statement, it will still finish running but will quietly return the special value none. Use this carefully and avoid storing none when you actually need data.